In this video, we'll show you how to convert binary into decimal. To begin, binary, otherwise known as base 2, uses only 2 digits, 1 or 0. And the way it works is as you go from right to left, each new value is doubled. So it looks like this: 1, 2, 4, 8, 16, 32, 64, 128, and so on. Or, mathematically speaking, as you move from right to left, each new value is increased by a power of 2. So the 1 is 2 raised to the 0 power, 2 is 2 raised to the first, 4 is 2 raised to the second, 8 is 2 raised to the third, and so on. Now, you want to focus on this row right here because these are the exponential math values written out, and it just makes our conversion easier. Okay, now we understand how the numbering works. Let's look at an example of converting binary into decimal. Let's say we're given a binary digit of 0, 1, 1, 0, 1, 0, 1, 1. If we focus on this row, we can see the corresponding decimal values. Now all we have to do is any place we see a binary digit of 1, just add the corresponding decimal value and ignore any zeros. If we add up all the 1s, we get 64 plus 32 plus 8 plus 2 plus 1, which gives us a decimal value of 107. And there you go. That's how it works. But let's do some other examples. Then we'll talk about fractional binary values and how to convert binary numbers that have decimals. So let's say we have a binary digit of 0, 1, 0, 1, 1, 1, 0, 0. Again, all we have to do is look for the binary digit of 1 and add up the corresponding decimal value. In this case, the decimal numbers are 64, 16, 8, and 4. If we add them up, that gives us a decimal value of 92. If we have a binary digit of 100101, that gives us 32 plus 4 plus 1, which equals 37 in decimal. Okay, let's move on and talk about how to convert binary numbers that have decimal values. All right, we know how to convert the numbers to the left of the decimal, but how do we handle values to the right of the decimal? Well, it's the same principle as before, but with a twist. The pattern is still doubling. 2, 4, 8, 16, and mathematically, they're still powers of 2. The main difference is, since these values are less than 1, they're negative powers of 2. And if you remember from math class, these negative powers are really just fractions. And an easy way to handle the negative values is to put a 1 on top of the value, and voila, you have your fractions. For example, 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8, etc. Admittedly, working with fractions is no fun, so it's really easier to convert the fractions into decimals because we eventually wind up adding all the numbers together like before. If we walk through the conversion, 2 to the negative 1 gives us 0.5. 2 to the negative 2 equals 0.25. 2 to the negative 3 equals 0.125. 2 to the negative 4 equals 0.0625, and so on. Going back to our example, let's convert 101101.1011 into decimal. Okay, now to convert this, we just need to do the same thing as before, which is add up all the values that correspond to the number 1. And in this case, it would be 32 plus 8 plus 4 plus 1 plus 0.5 plus 0.125 plus 0.0625, which equals 45.6875. How about we do one more just to reinforce everything? Let's say we're given a binary digit of 101011.101. Again, just look for the number 1 and add the corresponding decimal value, which in this case gives us the numbers 64 plus 16 plus 2 plus 1 plus 0.5 plus 0.125, which equals 83.625. All right, you might be asking, why does converting binary into decimal even matter? Well, the reason is binary is used in computers, and it acts as a translator between a computer's zeros and ones and the numbers we can actually understand. And if you work in, let's say, computer science, cybersecurity, computer networks, electronics, and even some data formats, knowing how to convert from binary into decimal is a skill worth having. Okay, and that'll do it for this one. Feel free to let us know your thoughts below. Don't be shy about that like, share, and subscribe button. And now here's another video.